So we have now come to the end of the chapter. Now we're going to talk about how time horizon plays a role in some important production decisions. So we're going to talk about a short run period and a long run period. Short run is a relatively short period of time, as the term implies, and long run is where it's a longer period of time. Now, the reason we bring in this distinction is that certain decisions in the production space cannot be made very flexibly in a short period of time. For example, if I want to set up another factory, or if I want to change the chip that goes into my computer, certain changes like this cannot happen really quickly. They need a longer period of time in order to be actionable. Whereas certain other things like hiring an extra worker or maybe getting an extra work desk or something like that, that is doable in the short period of time. So how these decisions pan out over different time periods is the subject of our discussion now. So let's dive right in. As I mentioned earlier, in the short run, we have limited flexibility in our actions, whereas there's greater freedom when there is a longer period of time. So the way this comes into our discussion of costs is that in a world where there are two inputs, capital and labor, oftentimes one of these inputs will be fixed in the short run. And we generally take it to be capital. Capital is often assumed to be fixed in the short run, meaning there is not much scope to change the amount of capital that goes into production. And labor can be variable because you can hire laborers with a lot more ease than by hiring, say, an extra unit of a plant or a factory. So the way we do that is to characterize cost functions in the short run and in the long run. So we go ahead and say that in the short run, capital stock may be fixed at some value K1 and we only allow labor to vary. In such a world, the production function in the short run then becomes a function of K1 and L, where K1 denotes the fixed amount of capital, which cannot be varied in the short run. And naturally, the cost function that follows is just going to be Vk plus Wl, but now K is fixed at K1, so we reflect that change also. Now we can think of two types of short run costs that arise. A part that is kept fixed, okay? So these are more the fixed elements of our cost, and then there's a variable element. Fixed costs are those that you will have to pay regardless of whether you use the input or not. So in the short run, when capital is fixed, any cost associated with use of that capital is treated as a fixed cost. So if you're thinking of an entire plant or a factory, whether you use that factory or not, you'll probably have to pay rent on that factory. So that will be your short-term fixed cost. And whatever cost is associated with the input that is variable is called the variable cost. So far we've actually been talking about a world where everything is variable, where we've been talking about the long run scenario. Now we're going to focus our attention on what happens in the short run and how it actually paves the way for the long run discussion. So we first need to realize that while our goal is to optimize costs in the long run, they may not necessarily be optimized in the short run. So suppose we are constrained to use K1 units of capital, and we're looking at a scenario where we're trying to produce different levels of output, Q0, Q1, and Q2. We are allowed to vary our labor input, but our capital remains fixed at K1. So let's see what's happening at Q0. Well, to produce an output of Q0, we're at this particular point that I've highlighted here. And clearly that point is not tangential. That point is not one of tangency between our budget line and the ISO point. If in fact we were to have tangency, we should probably move south in the southeastern direction, and the tangency will probably be achieved somewhere over there. So to optimize, we need more labor and lesser capital at that point. So production is happening at a non-optimal point in the short run. On the other hand, if we were focusing on Q2, a higher level of output, production happens here. Why does it happen there? Because we had curtailed in terms of how much capital we can use. So we have to use only K1 units of capital, and we're using L2 units of labor. Here again, certainly there's no tangency of the isoquant with the budget line. Tangency will happen somewhere here, meaning if you get more capital and less labor, you're producing at Q2 with a less expensive bundle. So, whereas if we look at the third case, here, optimal, this for Q1, it happens to be the point where your RTS and the price ratios are the same, so it works out that way. But the point to remember here is that this need not often always be the case. In short run, we may be operating at non-optimal points of production. So just a couple more terms to pick up along the way. We have a short-run average cost function, which is just your short-run cost function divided by output. We also have a short-run marginal cost function, which is just the derivative of the short-run function with respect to the output. So, and the properties here remain the same as they were in the earlier case that we saw. Now, we've defined what the short-run period is. And now in the next segment, I'm going to walk you through the relationship between the short-run and the long-run cost functions. So that may be a little challenging to wrap your heads around initially. So I'll put that in a separate video and I'll see you there.